For today's lesson, we're going to be solving equations that have radicals in them. And you can see in the top right, I've already posted your key instruction for this entire lesson that you should check all of your answers at the end of the problem in the original equation. So let's begin with this first example that says the square root of x is equal to 6. Now I have the variable that's underneath the radical sign, and this is going to be the principle you're going to use for the majority of these problems. How do I access x? How do I get to x? It's kind of stuck underneath this radical sign right now. This is representing the square root of something, so what I want you guys to do is to square both sides of the equation. Just in the same way that we could add something to both sides or multiply the sides of an equation by something equivalent, what we're going to do here is square both sides. I would recommend using parentheses to show this. And when I do that, when I square a square root, that's just going to give me the radicand, the amount that's underneath the radical sign. 6 squared is 36. Very easy first example. That's your only solution. Like I said, we would check that, put 36 back under the radical sign right here, take the square root of 36, it equals 6. So that one is good. We'll put a little check mark here. Next, okay, we still have just a square root of x, but there's some additional material surrounding it here. So I want you to, for a second, almost picture as if there were no square root here. I would add, if I had 3x minus 6, I would add the 6, divide by 3, and I'd have my answer. So let's follow that same protocol for this problem. I have to clear everything away from the square root of x before I consider squaring both sides. So if I add 6 to both sides, I have 3 root x equals 6. Now I'm going to divide both sides by 3. And I have root x equals 2. So follow the same steps as the last problem. To access the variable, I need to square both sides. X equals 4. Check your answer. If I plugged in 4 up here, square root of 4 is 2. 2 times 3 is 6. 6 minus 6 is 0. That checks. So, just 4. We will get to examples where when I check my answer, something strange happens. That's going to be in our last example here. One more example here. 2 square root of an expression now. So 2 times the square root of x plus 6 plus 9 equals 21. Same idea. Let's clear everything away from our radical before solving for x, before squaring both sides. So I'm going to subtract 9 on both sides. I'm a little tight on space, so just pretend that I've subtracted 9 on both sides. And we get down to 12. Now, like the previous example, I divide both sides by 2. Again, pretend that I've done that, showing my work. 12 divided by 2 gives me 6. Okay, so now I have an expression underneath the square root sign, but I'm still going to use that same principle of squaring both sides. That's the only way I can get to the variable. When I square this expression, it just stays as an expression. It just becomes x plus 6. What's the square root of x plus 6? Well, when I square it, it kind of unlocks that expression. 6 squared, once again, is 36. Subtract 6 from both sides. One solution, x equals 30. Remember to check. We'll plug it in. 30 plus 6, that's 36. Square root 36 is 6. 6 times 2 is 12. 12 plus 9, 21. We're good. This example is actually probably the easiest one that I'm going to show you on the board today. It's the square root of one expression equal to the square root of another expression. Looks way more complicated than it's going to be. I have 2 variables in this instance, but everything right now is trapped underneath a radical sign. So my only move here is to square both sides of this equation, which basically just unlocks everything. I have no more radical on this left side, 4x minus 12. No more radical on the right. So this just becomes a simple variable equation with a variable on each side. I would subtract x on both sides, and I would add 12 on both sides. We have 3x, cancel, cancel, 15, divide by 3, x equals 5. Important to check, 4 times 5 is 20. 20 minus 12 is 8, so we have the square root of 8 on the left side, hold on to that, and 5 plus 3 is 8, so root 8 equals root 8, that's true. Okay, this is important to check your solutions here. We have, first example, x equals the square root of 20 minus x. Notice that the expression over here is entirely underneath the sign. So since I've got a variable underneath the radical sign, I am going to go ahead and square both sides. Left side, I have x squared. Right side, I have this expression, 20 minus x. So I have a x squared term, I have a negative x over here, and I have a 20 additionally as well. This is a quadratic equation. We're not going to be able to combine the like terms of x squared and x. I'm going to get everything on one side of the equation here, zero out one side, and factor to solve. So I'm going to keep x squared where it is. Let's add x to both sides and subtract 20. So we'll do that to this side as well. Plus x minus 20. Everything equal to both sides. X squared plus x minus 20 equals 0. So we want to zero out one side of the equation if you see an x squared term. We're going to factor this left side. So I need factors of negative 20 that sum to 1. It's 5 and negative 4. Use the zero product property to solve. So x plus 5 equals 0. And x minus 4 equals 0. Two solutions this time. And we get negative 5 and 4. So I need to check both of these. Let's begin with negative 5. I'm going to actually show the check this time. So if I were plugging this negative 5 into the original problem, I'd have negative 5 equals square root 20 minus negative 5. Do one more step and we'll see why there's going to be an issue here. 20 minus negative 5 is 25. Does anyone see what the issue might be here? We have a negative sign opposite a square root. If I continued to simplify this right side, I would have positive 5. So that is not true. So negative 5 is going to be what we call an extraneous solution. You can see this in your textbook in section 11.3. So that is not true. Even though we did all the right steps, it is not a solution to this original problem. But 4, we need to check that one as well. So if I plugged that one in, I'd get 4 equals square root 20 minus 4. This one looks good. So that's true. So the only answer to this example right here is going to be positive 4. Kind of ran out of space, so we'll skip this last example, but that should cover the idea of an extraneous solution. So that last example is difficult. You need to square both sides, zero out one side, factor, solve, and make sure you check both answers if you get 2. Always check the solutions here to make sure that it's not extraneous.